jumping straight in, I have got a few that you're going to try this evening as well. So hopefully get you into practice, get you into the swing of things. If we have a look at this first example, oh, sorry, just walked past my window, give me a fright. Okay, we have got tan theta is equal to 3 over 4, and theta is an element of 180 to 360. Calculate, or rather without the use of calculator and with the aid of a diagram, determine the value of. All right, a couple of things here. When it says without the use of a calculator, often we think of special angles. Now, whilst that might be the case, because we have tan theta, theta is unknown. So we can't really use special angles here. What this does mean is that when you draw your diagram, you're going to get ratio values and you're going to have to show your working out essentially when you go find this value. So it's really show your working out. This aid of a diagram, we don't always say it, but it is something that you should do regardless of whether we say it or not, because it's really helpful. Right, so if we start with that diagram thing, because like I say, to answer these questions, we're going to use a diagram. We've been told, let's actually do this. We've been told that tan theta is equal to 3 over 4. And now remember on the Cartesian plane, tan represents y over x, your y coordinate over your x coordinate. Just as a reminder, sine theta on your Cartesian plane is y over r, cos theta, x over r, and like I've just said, tan theta, y over x. So they either represent an x or y coordinate, and then your radius or your hypotenuse. So we've been given a y and an x value. That's the first thing we were told. The second thing that we're told is that this is a positive tan. Okay, apparently not. Tan is positive. The fraction is positive, so tan is positive, which means that's either in quadrant 1 or quadrant 3, because that's where tan's positive. And then the next thing that we were told was this bit over here giving us the range in which theta exists. So if we think about this on our Cartesian plane, 180 to 360 is really only quadrants 3 and 4. Quadrants 1 and 2 don't really feature, because that is between 0 and 180. This is now 180 to 360. And like I say, tan is positive. The only place where tan is positive in those two quadrants is quadrant 4. So when I now draw my diagram, I'm drawing a diagram in quadrant 4 of my Cartesian plane. Draw it a bit better. Now guys, whether you draw it as a triangle or whether it's just a line, it really is up to you. It makes no difference. I like to just add in the triangle idea. It just helps me. But we are working with the angle theta. Remember, always measured from your positive x-axis anti-clockwise. And because we've been given tan of 3 over 4, you know what y is and you know what x is. Now guys, be careful. In quadrant 3, x and y are both negative. So this y value of 3 is actually negative 3, and the x value of 4 is actually negative 4. But it makes sense. Negative 3 divided by negative 4, positive tan ratio. So always just double check what quadrant you're working in to make sure that the sign of x and y is correct. The only bit of information I don't now have in my diagram is my r value. Now it's very easy for me to go and work out my r value. It's a right angled triangle. I just use Pythagoras. So r squared is equal to 4 squared or negative 4 squared. It honestly makes no difference. Plus negative 3 squared. This is all because of Pythag. And so your radius is 5. It is absolutely acceptable for you to just go straight to r equals 5 with Pythag as your reason. You don't have to show your working out. At this point, we kind of expect that you can do Pythag. Okay, now we've got all 3 sides of our triangle. We can pretty much go work out anything. So the first question is asking us to determine sine of 2 theta. Now we need to be careful. We were given tan theta, not tan 2 theta. The angle that I'm working with here is theta. This is a double angle, and so what that actually means is that I need to apply my double angle formula. Because I'm applying my double angle formula, I'm now working with the angle theta rather than 2 theta. And so I can now actually use my diagram. So if I go read sine theta off my diagram, remember sine is y over r. So this would be 2 times negative 3 over r, which is 5. times cos theta, which is x over r, so negative 4 over 5. You're reading all of this information off your diagram, okay? And that's why the diagram is so useful. You now go and multiply, and this is now where without the use of a calculator comes in. You need to show you're working out. This would be 12 over 25. Multiply that by 2, 24 over 25. All right, so when you're given questions like this, be mindful of what angle you're working with. In this case, we gave you a theta angle, but the question involved a double angle. So we need to apply our double angle rules. The same thing's going to happen now in question B, where we've got cos 2 theta. So let's just get rid of some of the space. Cos 2 theta, same thing. I'm going to use an identity. Grade 12s, remember, cos has 3 double angle identities. You need to decide which is most beneficial. Cos squared theta minus sine squared theta. 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Now, when you decide which is more useful to you, I would look at the questions you've already done. So in the question we've already done, we know what sine theta is and we know what cos theta is. So try and pick a ratio that involves one or both of them. What that means is you could actually use any of these. Really doesn't matter. Okay, so whichever one you want to pick, you go for it. I'm going to go with the 2 cos squared theta minus 1. But like I said, honestly doesn't matter because you got both sine and cos theta from question 1. So you can do what you want. Right. We know that cos theta is at negative 4 over 5. So we've got 2 negative 4 over 5 squared minus 1. And again, you don't just show you're working out as far as you can. So this would be 16, over 25 minus 1. 32 over 25 minus 25 over 25 is equal to 7 over 25. Guys, from this point over here, you can pretty much type it into your calculator and get an answer. I don't really need to see the LCD. We're satisfied that you can work out an LCD and you can go and add and subtract fractions. So once you sort of applied the squared, and the important stuff is that we can see the substitution and that you've done that correctly. So it's not the end of the world if you don't show every single minute step. It's fine. If you are concerned that you're going to lose marks, just show all the steps. Right, so that's the cos 2 theta. When we now get to tan 2 theta, what we need to bear in mind is that tan doesn't have a double angle formula or a double angle rule. Okay, tan is tan. But what you need to remember is what I said to you on Monday, in that the tan identity of tan is equal to sine over cos can be applied to double angles and can be applied to squares. So tan 2 theta is equal to sine 2 theta over cos 2 theta. In question A, you worked out the value of sine 2 theta. In question B, you've just worked out the value of cos 2 theta. So it's using what you already have to get the answer. So in question A, sine 2 theta was 24 over 25. And now we've just worked out in question B that cos 2 theta is 7 over 25. Tip and times. Simplify, giving you 24 over 7. Okay, so when it comes to these types of questions, what we need to be mindful of is what do you already have? How are you able to use it? How can you make use of the answers you already have, the information you already have to answer the questions that follow? Okay, so I'm going to make this a tad smaller so you can screenshot. And then like I say, you are going to give one a try by yourselves. Sorry if you can hear the ball bouncing outside. There's obviously kids playing basketball. Alrighty, so take a screenshot, and then I'm going to put up the questions that I'd like you to try. I'm going to give you 5 minutes. I think that should be enough time to give them a try, but it's the same idea. Use your double angle formula when necessary. Think carefully about the angles you've been given, and then carefully about what information you already have. Don't do more work for yourself. Okay, if it's already there, use it. Okay. So this is the question I want you to try. Please remember, guys, you have to isolate your trig ratio. So this is something that you should remember from grade 10. But anytime you're working with a Cartesian plane question, you always want to get your ratio alone. So we would need to get cos alpha alone by dividing both sides by 3. Only once you've done that do you have your x and your r value. So always just remember that you have to isolate your trig ratio first before you start working on the Cartesian plane. So you've got 3 questions there. Like I said, I'm going to give you 5 minutes and then we'll have a look at the answers. Okay, in grade 12s, just remember, ask questions as we go along. If you've got questions, please ask. You can raise your hand, you can put in the chat, whatever you're comfortable with. Remember, you're also welcome to put your answers on the chat if you want. Obviously, you don't have to, but you are welcome to. I'm going to give you 1 more minute and then we're going to have a look. Alrighty, guys, let's have a look. Okay, so again, make sure you isolate your trig ratio, because once you've done that, you can then go and have a look at what your Cartesian plane is going to look like. So based on the fact that cos had to be positive, and based on the fact that we were working between 180 and 360, it's terrible highlighting ability I had there, and based on the fact that it had to be between 180 and 360, we were able to determine the fact it had to be in quadrant 4. So that's my diagram over there, quadrant 4. Now, bear in mind, quadrant 4, x is positive, but y is negative, which is why once I'd worked out y using Pythagoras, I needed to remember that it had to be a negative 2. Okay, once you've done that, it's easy enough to go and work out the rest. So 2a, or sine 2a rather, sine double angle, you can get sine a and you can get cos a because that's the angle you were working with. Cos 2a, again, you can use any formula that you want. You don't have to use the 2 cos squared minus 1, it's up to you. And then tan 2a, you use your identity, that's sine 2a over cos 2a. You already have both of those values, so you can essentially substitute in and solve. So always just, with trig, it's think smarter, not harder, right? Especially when it comes to Pythagorean or Cartesian plane questions. Think about what you have. Don't redo work for yourself. If you have it, use it. Right, so I'm going to wait there in case you want to take a screenshot, and then we're going to have a look at another example whereby the angle that I give you is a little different, and now we need to think about that in the context of our questions. Okay. Right, so if we have a look at example 2, we've now been given a sine of 2a is equal to root 5 over 3, with 2a element of 90 to 270. Okay, so before I even get to the questions, I'm going to just unpack what all of that means. So sine of 2a, I'm being given a double angle here in my question. So when it comes to answering the questions, I need to bear that in mind. Sine is y over r. Sine is also positive. So that means I'm looking at quadrant 1 or quadrant 2. According, though, to the restriction I have, I only went from 90 to 270. So that means I'm going to ignore quadrants 1 and quadrants 4, meaning only quadrant 2 or quadrant 3, which means my diagram, because sine has to be positive, is going to be in quadrant 2. Again, guys, I'm sorry if you can hear the noise. Apparently, we are retiling roofs at the moment. Okay. Quadrant 2, we want to draw on the triangle, go for it. Like I say, it helps me. And we are looking at an angle of 2a here. Not a, 2a. You were given sine, so you've got the y value, which is root 5, over r, which is 3. And using Pythagoras, and bear in mind, obviously, that the x value is negative in quadrant 2. Using Pythagoras, you get that your x value is equal to negative 2. Like I say, it is perfectly fine for you to go straight to the answer, because you would just type it in on a calculator and get your answer. And then, of course, again, take note of where it is on the axis. Because it's negative x, it must be a negative 2. Now we've got all the information that we need. So cos 2a. Because I gave you the angle 2a, that's the angle we're working with. We don't have to apply a double angle. The angle that I have here on my Cartesian plane is 2a. So quite literally, all I need to do, because this is cos, and because cos is x over r, I literally just read off those values. Negative 2 over 3. And that's because of what the angle was that I gave you. Because the angle I gave you in the original question was 2a. We have a look here. The angles match up. So there's no need for me to do a double angle formula. So the same thing is going to apply now in question B. Question B, I want tan of 2a. Remember, tan is y over x. That's all I need to do. I don't know why I wrote it there. I read off y, which we know is root 5. Weird looking square root. Let's try that again. Over x, which is negative 2. Obviously, you can write this as negative root 5 over 2 if you want. But that's all we need to do here. Nothing else. And it's again because those angles match up. When, however, we get to question C, this is now where things are different, because I've now asked you for sine of A, not sine of angle 2A. And so now I need to be careful. So the question I need to ask myself is, what do I already have? I've got a cos double angle and I've got a tan double angle. Tan double angle doesn't really feature because we've got no rule that involves a tan double angle. So we can sort of ignore that. That cos double angle is going to be important. So the question I now ask myself is, cool, I know I've got a cos double angle. Which of my cos double angle formulas work with the sine of the single angle, of angle A? Now there's two of them. There's either cos squared minus sine squared, or there is 1 minus 2 sine squared. Now technically either one is fine, but the problem with the cos squared sine squared is you're introducing cos squared A. That means you're now introducing a whole new set of problems. So if we go and we say, okay, cool, I know that I've got cos 2A, and I know I'm looking for sine A, I can set up an equation that will allow me to solve for sine A. If I had gone with cos squared A minus sine squared A, I would be left with the cos squared A, and that's a problem. I don't know the value of cos squared A. I know the value of cos 2A, but not cos squared A. So I want to avoid trying to introduce new unknowns that I don't know the value of. Because I know what 2A is, I can substitute that in. And now all I'm literally going to do is solve for sine A. So that means I'm going to subtract 1 on both sides, which gives me negative 5 over 3 is equal to negative 2 sine squared A. I'm going to divide both sides by 2, or negative 2 rather, giving me 5 over 6 is equal to sine squared A. And we know that to get rid of a square, we square root. So sine A is equal to the square root of 5 over 6. Right, so this one's a little bit different because now I've given you the double angle. You almost need to work backwards from the double angle using the double angle value that you already have, and work back using the double angle rule to get the single angle according to the formula that you've chosen. So just always, and that's what I said to you in the first question, always take note of what angle you've been given. If it's a double angle and the angles match up, so for example, like in the cos 2A, that was also a double angle. There was no need to use double angle formulae. But in question, cos single A's based on the information we already have. So it's always important to go back to what you have, what you know, how can you use it to essentially get your next answer. Okay, so let's take a screenshot, manage to put it all on one page, and then you're going to try one by yourselves. Again, guys, please ask questions as we go along. These are the exam type questions you can expect, so ask if you're confused or not understanding. Okay. Right, so you're going to try this one. Please remember, as I've said already, that you need to isolate your trig ratio. So in this case, you are wanting to isolate the sine to theta. So you want to get that alone. So please bear that in mind before you get started. Also bear in mind that 2 theta is an element of 90 to 270. So that will help you with your diagram. And then we want cos 2 theta and cos theta. 5 minutes. I don't think you should need more than 5 minutes. Let's see how we go, and then we'll have a look at the answers. Okay, I'm going to give you 1 more minute and then we'll have a look. Okay, guys, let's have a look. All right, so if we, like I say, you need to first isolate your trig ratios. So you need to get that sine to theta alone. Once you've done that, you got 15/17. So sine's positive. It was somewhere in quadrants 2 or 3. So we're in quadrant 2 because that's where sine's positive. I made a mistake in this one. I thought I corrected myself, but I did not. So let's correct it. You had to work out x. Now remember, x in quadrant 2 is negative. So that should be a -8. Actually, let's do my corrections in a different color. So -8. So this should be a -8, which means this should be -8/17 in question A. When it comes to question B, again, double angle formulae, because you want cos theta. So find the formula that has cos theta and then solve. So this is -8/17, and then let's fix all of this. You're going to add 1 to both sides, which was, I'm going to lie if I say anything, 9/17. Divide both sides by 2, 9/34. And so square rooting, you get square root of 9/34. Now, guys, obviously remember, when you square root a fraction, you're square rooting numerator and denominator. You can square root 9, you get 3. But we never really try and leave, or we're trying to avoid leaving a square root in the answer. So if you type that on your calculator gives you 3√34/34. Remember, what it's doing is it's rationalizing the denominator. So it's timesing that by 34, because √34 times √34 is just √34. The square roots essentially cancel out when you square them. But what you do to your denominator, you must do it to your numerator. This is not something you need to stress about. If you leave it as square root 9/34, that's fine. If you left it as 3/√34, that's fine. I'm just letting you know that if you were to type that into your calculator, you will get something that looks different. And it's because your calculator rationalizes the denominator. Okay. Excuse me. Let's take a screenshot. And then the next example we're going to have a look at is now where we introduce variables to our trig on the Cartesian plane and just how we deal with that. Honestly, it's not any different. It just means that our answers are going to be in terms of a variable, and we just need to be mindful of that. Alrighty. Okay, so if we have a look at this third example, like I said, we're now dealing with a situation where we have a variable. So we've been told that cos 25 is equal to k, and we want to determine the following. Now, 25 is an acute angle. So what that means is you're working in quadrant 1, or if you want, just in a normal right angle triangle. That looks like a slice of cheese. So let's try that again. So just a normal right angle triangle where one of your angles is 25 degrees. Does mean that you can work out the other angle. There would be 65 degrees because of sum of angles in a triangle. But obviously, based on what we've been given, we've got the 25. We were told that cos 25 is equal to k. Now remember, that can technically be written as k/1. That's your opposite over hypotenuse. No, it's not, because it's cos. It's adjacent over hypotenuse. So this would be your k/1. for your hypotenuse, which it doesn't want to write down right now. So 1 down there. And what that does mean is that you are able to work out your opposite side. Okay, so the opposite side, again, using Pythagoras, would be hypotenuse squared, so 1 squared minus k squared. Sorry. I don't know what's happening. Okay. Now, obviously, we don't want opposite squared, we want opposite. So the opposite side is equal to the square root of 1 minus... Oh, sorry. Sorry, Gretelps. Came out of nowhere. Your opposite side is equal to the square root of 1 minus k squared. Oh, apologies. So now we know all three sides of our triangle, and we can go and answer the questions. Okay, so the first question is cos of 155 degrees. Now, nowhere in my triangle do I have a 155 degree angle. It's not a double angle of any of those ones I have there. Double 25 is 50. You can see that's going to come in question B. Double 65 is 130. So not a double angle. Think back to your basics. Think of your reduction formulae. If we take cos of 180 minus 25, we get 155 degrees. So we can reduce the angle here. Now, 180 minus is in quadrant 2. This is where cos is negative. So we're actually working with negative cos 25 degrees. That's a weird situation. Let's try again. Okay, there we go. Now, we already know that positive cos is k. So negative cos 25 is negative k. And that's it. Okay, so when it comes to these questions, often we ask you to apply a reduction or potentially even a co-ratio. But as you're going to see now as we go along, we can also ask double angles, compound angles, etc., etc. So this one, just a reduction, 180 minus quadrant 2, cos is negative, negative cos 25, so negative k. If we now have a look at question B, though, we've got cos 50. And as we can see, this is definitely a double angle, because 25 degrees times 2 is a double angle. So we can break this down to cos of 2 times 25. And this is now where we can apply our double angle formulae. Now, because it's a cos double angle, apply any cos one that you want. But remember, look at what information you already have. You already know what cos 25 is. So try and use the double angle formula that contains cos. So I'm going to use 2 cos squared, minus 1, because I already know, just maybe put in the angle, 2 cos squared 25 minus 1, because I already know what cos 25 is. I was given that information. So it would be 2 times k squared minus 1. And so cos 50 is 2k squared minus 1. So it all goes back to what I said. Use the information that you have. There is no point in trying to find extra information if you already have what you need. We already had cos 25. The double angle splits into 2 cos squared 25 minus 1. There's nothing else I need to work out. Right, if we have a look at the next one, we've been asked to find sine of 25. Make that up a smidge. Right, sine of 25. I've got my 25 degree angle in the triangle. I just read it off. Sine, remember, opposite over hypotenuse. We had to work out the opposite. It was at root 1 minus k squared. The hypotenuse is 1. So actually, this is just root 1 minus k squared. Again, it's reading it off. You did the hard work up here when you did the Pythagoras. Now it's just about reading values off. If we now look at question D, though, we've been given sine 50. And again, we should be thinking, cool, that's a double angle. Now for sine, there's only one double angle formulae. So sine 25 times cos 25. You know what cos 25 is because I gave it to you, and you've just worked out what sine 25 is. Nothing else you need to do. So sine 25, we've just worked out to be 1 minus the root, or rather the root of 1 minus k squared. Cos 25 is k. So when you multiply this all together, 2k root 1 minus k squared. The answers don't look nice. The answers are complicated, but actually what you've done is very easy. You've used the diagram in order to help you answer your questions. Now, what I want you to notice as well is that nowhere in the actual question did it say, and with the aid of a diagram. We just drew a diagram. And that's what I said to you at the start. Being able to draw these diagrams is so useful for yourself. Even if it doesn't ask you for a diagram, do one, because it honestly just helps you so much as you go through these types of questions. Right, but let's take a screenshot, and then you're going to try one by yourselves. And then hopefully, I'm sure we will, we'll have a look at the last two questions that we have, whereby we can introduce a compound angle situation. Okay. Right, so give these 4 a try. I don't think you need more than 5 minutes, even though it's 4 questions. The first couple aren't too tricky. Right, so give it a try. Like I say, 5 minutes, and then we'll see where you guys are at. Okay. Okay, 1 more minute, guys, and then we'll have a look. Alrighty. Okay, so again, look at your ratio that you've been given. Isolate what you need to isolate. In this case, you didn't need to isolate anything, but if you do, just remember to do that. And then you can draw your diagram. So here, again, it's an acute angle. You can draw it in quadrant 1 if you want, or you can just draw the triangle. It's up to you. But essentially, you can go from there. Right. First one should not have been too tricky. Nice and easy. Cos 18. Quite literally, just read it off your diagram. The 78, sine 78 in question 2. That definitely might have been a bit tricky. And this is sort of where the compound angles come in. Now, we haven't done an example like this. So if you found it tricky, it's absolutely fine. It's more just to see if you could do it. Because 78 isn't a double angle, it's not the third angle of your triangle. You now need to think of how else you can work with it. We can't really use a reduction, all right? Because it just doesn't really make sense to use a reduction. You could, if you wanted to, use a co-ratio. No, you couldn't. Sorry, I'm just talking nonsense. Can't use a co-ratio. And so now you need to think of, okay, I've been given 18 degrees. How can I use that? If you think of the special angles that you have at your disposal, you could have said sine rather of 60 plus 18. 18 was given to you. 60, oh gosh, 60 is a special angle. So when you expand this to sine 60 and then the cos 60, you can write out what they are. All right, so we had to use compound angle formula here in order to get the sine 78. Like I said, if you didn't get that, don't stress. It's not one that we've done an example of yet. I just threw it in to see how you dealt with it. Then when we get to question C, sine 36, double 18 is 36, so nothing too tricky there. And then 198, that's a reduction. So everything except for B should have been pretty straightforward. Only B we might have struggled with. If you didn't, well done. If you did, don't stress. Like I say, we're going to have a look at an example like that now in a second. It's more just how did you cope with it? Did you think outside of the box there? Okay, so let's take a screenshot and then we're going to do one more. Right, I'm going to skip to question B, mostly because I want to talk about the compound angle situation. It's pretty much the same idea as question A, so it really doesn't matter that we're skipping. Right, so if cos 55 is equal to P, determine the value of cos 5 in terms of P. Okay, cos 55, acute angle, whoops. So nothing I need to stress about there. I can draw my triangle, no worries. So there's my 55 degrees, right angle. This would then be 35 degrees if I use sum of angles in a triangle. Cos is adjacent over hypotenuse, so P over 1. And using Pythagoras, you get that your opposite is equal to square root 1 minus P squared. Oy, oy, oy. Okay, there we go. So we want now the value of cos 5. Now, if you have a look at what you've got here, you've got an angle of 55, which is definitely not double 5. You've got an angle of 35, which is also definitely not double. You can't use a reduction. You can't use a co-ratio to get any of the angles that you have here. So we're a bit stuck. But go back to what you have. You have got 55 degrees and you are wanting 5 degrees. If you think of the relationship between two of them, if you add them together, you get 60 degrees. That is a special angle. So what we can do is we can now use that relationship to say, well, okay, I could write 5 degrees as cos of 60 minus 55. The 60 is a special angle, so it doesn't matter that it's not in the triangle. I can work with the special angle. And the 55 degrees was the angle given to me. I know all of the information here now. Now, because it's cos A minus B, when we expand it, we get cos 60. Oh, please don't fight with me. Cos 60 times cos 55 plus sine 60 times sine 55. And now I go and work all of that out. Cos 60, special angle, a half. Cos 55, that was given to me in the question, so that's just P. Plus sine 60 is root 3 over 2. And sine 55, we weren't given that information, but we can work it out. Sine, opposite over hypotenuse. So this would now be root 1 minus P squared. Now we can't really do much with this. This is just a really gross looking expression. But what you need to remember, guys, is that you can use compound angle formulas. If there is no way for you to get a double angle, a reduction, a co-ratio, anything like that, then see if you can work it out with compound angles and a special angle. There's nothing wrong with doing that. You're just applying rules that we already know are true. But always then look at the relationship between the angle you have, the angle you want, and if you can get it to a special angle. So in that last question, what was it, sine 78 or whatever it was, I'll come back to that now, sine 78, it had a relationship. If you took 18 and you thought about the special angles that you have, so for example, 60 plus 18, you get the angle you wanted. Similar thing here. I looked at what I had, thought of my special angles, and I was able to go and use everything that I was given, everything that I already know in my special angles to get my cos of 5 degrees. Okay, guys, so take a screenshot